You see, we got a router. This need not to be a router. Uh, it should be a router or a routing capable device. That is important. It can be even a multi-layer switch with IPv6 support. So why I'm emphasizing that, because not every time we will have a router connecting a LAN. Sometimes we'll have a distribution switch as a layer 3 uh, switch. So now on the access layer side, the access layer side is L2 and the distribution layer side is L3. So that's how we will have a switch connecting to many access layer switches, layer 2 switches. And this is a distribution layer, access layer. And we will have many devices connected to this. Now, in early days, in IPv4 world, we used to have a DHCP configured. Not everyone configures DHCP server on a switch and routing. Some people will use Windows operating system. Some may be using a wireless access point. But there is also an option, no, to use Cisco's device that put it on a switch to be a DHCP server. And what will happen is the devices will send a layer to broadcast. Because it's a broadcast, every device on that VLAN will be receiving the broadcast packet, which is not safe. So in IPv6, what they did is they want to remove the concept of DHCP. They do not want a server giving an IP address. IPv6 is designed to know their network using ICMP version 6. After knowing the network, the devices will use their MAC address to form a unique IP address by attaching its own MAC address, the EUI 64, as an interface ID. For example, for each VLAN there will be a gateway address. Let's say for VLAN 10, the gateway address is :1/64. Now what will happen is, this will send a route solicitation. This will send a route solicitation. Is there any router here? And then this will say, I am a layer 3 router, and it sends a layer 3 route advertisement array. In that, it will also advertise prefix. So it advertises saying, I belong to 2010::/64 network. That is what going as route advertisement array. Array is the reply of RS. RS is a request. Now this device understands, okay, I'm connected to a network called 2010. Then what I should do, I should take my MAC address, add it to this 2010 so that I can have my own IP address. What an idea, no? Likewise, this device will also have its own MAC address added here. So every device adds their own MAC address with the extension EUI. Since you remember I told you FFFE added in the middle of the MAC address, and the seventh bit from the left is inverted. But for that, what is important is this device need to be a router. By default, IPv6 routing is not enabled. When you say IPv6 unicast routing globally, all the interface is becoming capable of IPv6 support. All the interface will join a new multicast address called FF02::2. Only to this address, this route solicitation will come from the PCs. So if this is not a router, it won't be a member of this multicast group. And this won't work. Stateless, auto, address, configuration will not work. It will not work. Stateless auto address configuration will not work if this multicast group is not joined by this device. Just to receive that to receive that route solicitation, it needs to be a member because the route solicitations are sent to this FF02::2 address. This is what I'm going to show you now. The title is SLAAC, Stateless Auto Address Configuration. So I'm going to take one router, and via a layer 2 switch, I'm going to connect many computers. And I don't have any computers. I don't think this VPC will support. Let me check. If the VPC don't support, then I'll use a router as a computer. This computer should get an IP address dynamically without any DHCP. IPv6 address. I don't think IPv6 is supported here. So instead of computers, what I do is I am going to use some routers. 1, 2. 2 and 3 are clients, which is going to, I should not call it as client because there is no server here. R1 is not going to be a server. It is simply going to advertise its prefix. It is not going to advertise any IP address. As a route advertisement, it is going to say I'm router, I'm this address, I belong to the subnet. That's all. So there is no real client server relationship. That's why it is called a stateless So if you see on router 2, I will say the IP address need to be auto-configured. On router 1, what I'm going to do is I'm going to assign an interesting IP address like colon colon 1. So this is the IP address that I'm going to assign on F00 of R1. Now, if R2 and R3 needs to ping R1, they need to be member of same subnet. But I'm not going to configure any IP address in that same subnet. It will be auto-configured. And you will know very well why or how it happens. Because we have learned the 5 different type of messages, ICMP messages in the previous class. See, on router 2, I'm going to say, before that, let me go to router 1 and enable debug. Router 1 is actually not enabled. I'm enabling the interface F0/0 Norshad IPv6 address DAD ABC DAD PC :1/64. Debug IPv6 packets. Right. We have assigned the IP address, but there is no one to communicate to this because R3, R2 is down. Now, on R2, also I would like to enable debug IPv6 packets. Debug IPv6 neighbor discovery. And now what I'll do is on R2 interface F0/0 no shut. You see, please focus IPv6 address auto configure. That's all I'm doing. I'm not giving any IP address. I said you have to get configured by yourself. And now what happens is this guy immediately he says, okay, I'm sending a route solicitation. Who is sending? R2 is sending. RS. Hey, any router, please tell me, no? Any router there? Speak to me. I need something from you, please. Is there any router? So it puts its own MAC address, link local address, and it is sending to this multicast address. But this poor guy will not get any IP address, will not be able to build its own IP address. You see here, do show IPv6 interface brief. You will find only the link local address, but you will not find any. You will find only link local address. You won't find any global unicast address. With this link local address, you cannot ping anyone. This is for these machines to communicate, to know each other, like route solicitation that you see. So address is not coming. The reason is there is no real router according to IPv6. None of this is enabled with IPv6. If you go and see on R1, See, R1 is receiving a route solicitation, but it is receiving in the form of a neighbor advertisement. What a funny thing. Because it's not a router, according to IPv6, because I have not typed IPv6 unicast routing in the global configuration mode. See, show IPv6 interface F0/0. It is not a member of : 2. It is just a host multicast. So according to this device, I am a computer. According to this device thinks it's a computer. But actually it's a router. No, we need : 2 there. Only then, this subnet will be advertised as route advertisement, and R2 can learn that. For that, I need to say IPv6 unicast routing. And now if you see, it has joined the : 2 group. As a result, let me go up and I'll stop the debug. And I would like to show you. See, this is where we saw there was a route solicitation sent. But if you go down, you will see a route advertisement is received from router 1. How do I know this is router 1? That's my guess, but you can go and verify. Router 1, if you go and check show IPv6 interface brief, and I'm sure this will match there. You see, it's matching, you see. Yep. So router 1 is advertised saying, yeah, it's me, man. And it's also sending the MAC address and so on. And then what happens later, it also sends its own IP address. It says, hey, no, not this one. Before that, in the route advertisement, you will see DAD advertised. Come on, it didn't come here. Couldn't capture that. Let me see whether it is shown. See, it will advertise this prefix. This is what called as route advertisement. It says my MTU is this. This is my network. That makes this router to decide on its own IP address. You see. So the address manager has said, this will be my IP address. And it is sending for DAD. Is there anyone? No one objected. So it has auto-configured this IP address. See, R2 has got show IPv6 interface brief. It has got the address which will be allowing to be a part of that same network in which R1 is. We did not configure this. That network portion is automatically learned through route advertisement because R2 are sending a route solicitation. From the route advertisement, R2 knows the network portion of R1. So if I need to talk to R1, I also need to have the same network portion, DAD : ABC. So what R2 does is it takes the network DAD : ABC and takes the MAC address. The 48-bit MAC address is extended to 64-bit by adding FFFE. and inverting the 7 bit in the left. Same like what you see in the link local address above. C802 7FF FE F4 8. And this address of R2 will not conflict with anyone because everyone is going to use their own MAC address. Now, if I want to ping router 1, I can ping, you see, DAD colon ABC colon 1. I'm able to ping with the address which is auto configured, not via DHCP. Even in R3, you see. So, currently, there is no IPv6 address. Currently, there is no IPv6 address. Show IPv6 interface F0/0. There is no IPv6 address. Now I'm going to say interface F0/0 no set IPv6 address auto configure. That's it. On this router, you don't need to type IPv6 unicast routing. Only R1 should be a router to provide you the route advertisement. Now, if you go and see the same command, you already got the IPv6 address. Router 3 knows the network to which it need to be, and it took the MAC address and it has made its own. So if you want to ping, you can ping DAD colon ABC colon 1, which is router 1. What? DAD, not B. And now if I want to ping router 2's address, this is router 2's address. I can ping router 2's address. Yeah. So no DHCP needed. The multicast address FF02 colon 2, which is used by route advertisement, and multicast address FF02 colon 1, which is used as a neighbor advertisement, is more than sufficient to receive the subnet to which it needs to be a member so that it can communicate to the others. By taking the MAC address, they derive their own unique IP addresses and they are able to ping each other. Any questions? Any question or questions? Stateless auto address configuration. Are you confident on this subject? Did you understand how it works?
Kind of. So these routers are, typically these R2, R3 routers are acting as hosts here. Is that how the host would also behave?
Of course, yes. Host will also behave the same way. As soon as you say auto address configuration, immediately they will send a route solicitation to the multicast address FF02 colon 2. Every computer will do this. And the router will send a route advertisement along with the prefix information and the MTU size information which I showed you in the debug. Even in the presentation somewhere yesterday, I think yesterday or the day before yesterday, I was telling you what all will be shared as the route advertisement. That helps the PCs, the computers, to know what network they need to be a part in order to communicate to R1 and others. So now all three belong to same network, DAD colon ABC. They all are one LAN, local area network. Now, if I shut down R1, will it affect R2 and R3? No, it won't affect. Given is given. Actually, R1 did not give any IP address. R1 was simply doing route advertisement. Using that, R2 and R3 has generated a unique IP address. So the role of R1 is over. Route solicitation came, route advertisement done. Boom. There is nothing more router 1 has got to do with this. It is router 3 and 2, router 2 and 3 derived an address out of that prefix learned through the route advertisement. After that, they send for DAD. The address manager will send it for DAD, asking, hey, I think I can use this IP address because I have made this IP address out of my MAC address. Is there anyone here to object this? No one is going to object because it is made out of MAC address of the local device. So router 3 and 2 will say, okay, fine, then I'm fixing this address as my own. In that way, the others will also know about this. That is what called as neighbor advertisement and neighbor solicitation, which we saw in the previous class. So before you ping, everyone knows about all other in the same VLAN, same subnet.
So an IPv6 host will have full IPv6 information
Yes.
about another host in the same
Yes.
VLAN.
Yes.
Okay.
End to end. End to end. It will have all the LANs, all the LAN devices. They know. That is what called as host to host connectivity, end to end. The true end to end connectivity you will see only in IPv6. Even in IPv4, every device will know about all other device MAC address in the ARP table, but not
Unless it has
unless they generate some traffic to communicate to all
traffic
of
to it.
them.
Yeah.
That's not true end to end. But before before IPv6, when we were talking about IPv4 in OSI layer, we used to say host to host connectivity, end to end connectivity provided by TCP IP layer, means transport layer. That is not true, okay? Unless you have TCP connectivity, three-way handshake, then only the connection establishes. For three-way handshake, ARP is also involved. So that was simply, the word they used, host-host connectivity. But the real host-host connectivity you see only in IPv6. Right. Anyone else have got a question? Why do you need DHCP in IPv6? The DHCP in IPv6 is going to be only to provide a gateway address. See, the computers need not only IP address, they also need gateway. The gateway address needs to be given to every device in the LAN. Address will be auto-configured, same like this, but the gateway is going to be maybe R1 in our case. So everyone should know that R1 is the gateway. DAD colon ABC colon 1 is the gateway. Everyone should know this. For that, someone should advertise to everyone, for which we will use DHCP. Not only that, some of you may be using a Win server or an Active Directory or something like that. Okay, you also need to provide a DNS address to everyone. So we use the DHCP service to do those things. And again, this DHCP will not use broadcast. It will not use broadcast. It will use only multicast. whereas in IPv4 DHCP, it is the broadcast used, whereas in IPv6 DHCP, which is a stateful DHCP, address is stateless auto address configuration, whereas this DNS and VINs and all stateful, that will use multicast. All right, that part of DHCP we will see in our next class. Right, in this class we saw only one thing, how auto address configuration works. I hope you understood fully, not a kind of. I hope you understood this auto address configuration fully. It is purely based on what you learned yesterday. The route solicitation followed by route advertisement that helps to derive a unique IP address. Yep. Fine then.